All right, welcome everyone to our next live stream. Today is the guest is Renaud, the developer of Malcat. And so if you haven't checked out Malcat as a binary analysis tool, a hex editor, a decompiler, disassembler, maybe not a decompiler, but a lot of different capabilities here. You'll get a really good introduction today. Definitely check it out. There's a light version or a free version, and so it's easy to get your hands on. Before we get started, just a couple of channel announcements here. I'm going to share my screen with everyone. Assuming I can find the right tab, that is. There we go. So live stream schedule. You may have noticed the Malware Monday series has been on a bit of a hiatus. It just has gotten a little busy as I've gone back to work after a little bit of time out of office. Apologize for that. I'm trying to get back on track, but I've got some travel coming up here, and it's just proving a little more challenging than usual. I do have quite a few live streams planned, though. And you'll see, of course, today with Malcat, Kyle Cucci is on the October 16th. We'll be talking about his book, Evasive Malware. He's going to be coming prepared to do and provide some demonstrations and some hands-on. So, definitely come and check it out. And if you haven't gotten the book, maybe this will be the motivation you need to pick up a copy. The 18th that week, Doug Burks of Security Onion fame will be coming on to talk about Security Onion. They're going to be fresh off of the Security Onion conference, and so he'll have some really interesting things to show us and share with us about the latest and greatest with Security Onion. I don't think I have anything out further than that, but I do have additional guests. We've got some folks coming on to talk about Mac malware and a number of different things. So, stay tuned. This is the sort of the tentative schedule, and I'll get that updated as I get the actual stream scheduled and get things confirmed with the guests as we get a little bit closer to those dates. If you haven't checked out the channel, then here you can see next live stream is already ready. The Lockbit series, I've got the final video ready to post. I just haven't got it produced yet. Hoping to get that done yet this week, but you'll see it's a 9-part series that covers pretty much everything that I wasn't able to get into in the workshop at DEF CON. I have a tendency to over prepare, so definitely check those out. Those are some of the latest videos there. And then again, memberships. Thanks to all the members that have joined over the last few weeks since launching memberships. Your support and help mean a lot, and is helping me to really plan and plot a future for the channel. So let's stop that. I'm going to go ahead and bring our guest on today. Renaud, how are you?
Hi.
Thank you so much.
Everybody.
Yeah, thank you so much for taking the time to join. I know you're in Europe, and so we've only got time zone differences, but just the chaos of life. I know you provided me with a bio, but I figured it'd probably be just as well for you to introduce yourself and provide a little bit of background here as we get started.
So, hi everybody. First, thank you, Josh, for giving me the opportunity to talk about my tool. Like every programmer, I really like to talk about my software, of course. Also want to apologize for the awful French accent. I'm French and I live in Germany, so the English accent is not perfect. So sorry for you guys. You will have to endure it for some time. Yes, my bio. How could I introduce myself? I think, like many of you there, I started with computers pretty early, like I was 10 or so on, with a really old computer running, I think it was an 8088, running DOS, and learned some basic. And back then, with the computer, you got a manual, a basic manual, and there was one chapter, which was really interesting, which told you how to extend your basic interpreter with assembly. I was 10 and I found this chapter completely fascinating. I didn't understand anything at all, of course, registers and so on. I had no clue. But well, that's what woke my interest, I could say, in the field. And so, I've driven deep into operating systems, computer security, viruses, and so on. And so after that, I did some, I did a master in computer sciences in France. And then my first job was for an antivirus company from Germany, Avira, where I learned a lot there. There was a lot to learn because, of course, I grew up with some, online magazines like 29A, EKX, the old virus writer magazine. So I had a bit of background on computer viruses and so on. But the problematic of detecting viruses and malware in general is really completely different to, studying some old school malware. And I've learned really a lot there. I was in a really great team. And I've stayed, I think, for 5 to 6 years. I was in a team. I was hired as a developer, and I was developing the heuristic engine for PE files. So basically, my job was to improve the scanner of Avira in order to detect PE files with heuristics. Heuristics, you could, I'm just explaining for if there are some beginners there. Heuristics is you don't detect files using signatures or emulation. Heuristics is detecting files using anomalies, we could say, like looking into the PE format and seeing, oh, that is strange, and combining a lot of different anomalies to make great detections. Avira was famous back then for a few years, like 2010, for its heuristic engine. And yes, it was really great to work there. After that, I worked a bit in incident response in France. So normal stuff, answering to your typical ransomware attack and so on. I did also a bit of research and development. I focused on the creation of a sandbox, hypervisor-based sandbox, so based on KVM. And then I moved back to Germany. And now I'm working for a company that is named NSIS. It's a small German startup that is also doing incident response and developing an antivirus engine focused on documents like PDF documents, Office documents. So we use machine learning to detect this type of files.
Okay. Office documents are not down, and they're kind of down, but they're not out, are they?
No, not yet. Not yet. They always find a way.
Yeah. Well, here is. I'm going to bring the website up just to show everyone here. There's a link on the screen, and here you can see just the homepage for Malcat, malcat.fr. You can go ahead and download. You can see the highlights. So yeah, I guess I was right. Disassembly and decompile. A lot of features here. I've just myself started using it in the last couple months, and I guess I'm probably like many a creature of habit in that I have my tools and my workflow, and it's always a bit of inertia to add a new tool in. But I'm doing it, and I'm really enjoying the capabilities and just how a lot of times just how quickly I'm able to get to the information I need. I've done a few maybe more boring videos about PE file format stuff here recently where I've been able to highlight and use the tool. When did you start development, and what was the motivation behind creating, not just a hex editor on steroids, but just a full featured reverse engineering tool?
Sure. The when, it's rather easy to remember. I started in 2020. When I was working for Avira, I was doing some home office. And I mean, home office was not really my thing. So I think it was in February 2020. I said, oh, I will just leave and I will find something else where with colleagues and on site. Enough of this remote work. And okay, it was February 2020. So 1 month later, COVID-19 was there, the lockdown in Europe. And okay, no luck at all. And so I was stuck. I was looking for an on-site job during 6 months, and I used these 6 months to start Malcat. So we could say 4 years of development.
Okay.
Soon to be 5. And the why, it's because, in my opinion, at least, there is a gap in the tools for malware analysis. Like you have the big picture tools, like they give you some information, generic information, like Detect It Easy, P Studio. You get overview information quite rapidly. And you have the deep dive tools like IDA, Ghidra, Binary Ninja. But in between, you have, at least in my opinion, you have a gap where maybe there is a hacker's view that could fit in the middle. You can inspect a file and you can run some plugins, but beside Hue, there is not a lot of tools. And I think there is a need for this kind of tools for some specific jobs, at least, like malware analyst or everybody working for a SOC, for instance, a security operating center, when you need to triage, to do triaging, okay, a lot, when you have to look at a lot of different files every day, you need a tool that won't go as deep as IDA, but still deeper than P Studio or Detect It Easy. And when I was working at Agira, we had to hire some guys from time to time, and we did some interviews. And our interviews, it was mostly triaging exercises. Like, we give you a binary, tell us what you think about it, what is it, what does it do, is it malicious or not? And of course, we were developer, but a big part of our day job, of our daily task, was to inspect files, to look for new heuristics to develop. And most of the people that applied, I'm sure they were really good reverse engineers. Like, I'm pretty sure, but for this type of exercise, they were not good. They just deep dive into a binary and lost themselves following calls and so on, but they didn't get the big pictures. Like, you didn't need to do this. You could just look in the resources. There is some weird data blob. You could unzor it and you get the next stage immediately. Or don't reverse this part. I mean, it's just the auto hit runtime, for instance. Please don't do it. So the ones that performed the best were mostly people from Russia using Hue. And that's when I thought it would be nice to have something like Hue, maybe a bit better and a bit more modern, because Hue is running DOS.
Yeah. Oh, cool. I think you're right on. It definitely is filling a gap, and capabilities, and just moving through. I mean, I think as someone who tends to do reverse engineering, it's very easy to say, okay, every path leads to IDA. when you always want to start your analysis doing basic triage. And the more you can learn during that triage, the better equipped you are to decide what are the next steps, and to hopefully avoid any unnecessary time. Because the moment you open up a disassembler like IDA, like the potential for your time commitment and effort is just you're on an exponential curve there. So you have to be very careful. So that's really cool. You've got one feature request that came in. I don't know if you're in the you were expecting that, but here you go. Asked if you could provide a capability to inspect MSI files. So
there is already the capability for MSI files in theory. If you press F4, the decompile view on MSI files, you will get a dump of all tables, and you can search for the custom action table. I don't know if it answers your question.
Yeah,
but
hopefully that's there. So
there.
Not a feature request, but I guess an instruction on how to accomplish it. So that's awesome. Well, we have we have a demo scheduled. Would you like to get into the demo at this time? If anyone has any questions during the demo or throughout the entire live stream, please feel free to go ahead and ask those, and I'll be doing my best to work those in here during the session. And anything that's maybe more of an after demo question, we'll save those for the end. So we should be able to get through all of them.
Yeah, don't hesitate to interrupt me. I'll be doing a demo because, presenting a user interface through slides and, it's a bit boring, to be honest. So we have enough malware. We can showcase the tool on some malware. And yes, I will present some of its features. Don't hesitate to ask questions, in particular if you are new or you never use the tool. There is a lot of features in Malcat, and I won't be able to present them all. But the sample I've chosen is rather interesting. It's an old sample, but it will allow me to showcase a few of Malcat features. So I will move the stream on the side,
and I think we are. There is a bit of a blog post here.
Yes, if you want to follow what I'm doing,
there we go.
There is an old blog post when it's a bit outdated, so maybe I will do things differently today. But if you are lost, don't hesitate to refer to this.
Yeah, that's can be a hard thing, creating content, whether it's blog or video. I have this happen to me enough where I'll create a video with some, somebody's tool, and they'll actually watch it, which is always awesome. But then they'll say, by the way, there's a better way to do that. And either I'll learn that I was using the tool in the not maybe the most efficient manner, or it's because they've got a new feature was added since the video. And so I'm like, oh, well, maybe I need to make a new one. But if only I could just spend my days making YouTube videos, I probably would. But okay, we are ready whenever you are, if you're able to share your screen.
Share screen to do your entire screen. Hop. Oh, it's also my first time doing any kind of streaming, so please don't be too harsh with me.
Okay, we'll go with this view. If you could maybe make things just a little bit larger. That's the only real challenge with the streaming is usually you have to have the fonts and things bumped up so that you lose a lot of your desktop. But yeah, that looks pretty good. And let us know if there is anything. I'll keep our videos off to the side, and if there's any issues with view, let me know in the comments.
Okay, so the sample we will look at, it's an old sample from 2022. You can find it on Malshare. That's where I got it. And the font there, is it okay? Or do I need to make things bigger too?
Maybe a little bigger, if you could, yeah.
Little bigger? Okay. So interface, let's make 11. Yeah, sure. It's a bit bigger. Is it enough?
Yeah, I think so. Looks good. Oh, no, a little bigger. We got a request. A little bigger.
Okay. No problem. Need bigger. It's 30. Okay. You have to restart the software. It's not optimal.
Yeah, I think that looks good. How's that, everyone?
Good?
Good. Yeah. I think so. Let's go with it. If anyone lets us know it's still too small, I'll let you know.
Okay. So in this case, this file, it was a document. When you first start Malcat, you are welcome with the first view. Malcat is divided in a lot of different views, like you can see up there, the different icons. And the first view that you will see is a summary view. If you are new to the tool or if you are a beginner at malware analysis, it's you will get already a lot of information in this view. In this case, we are looking at a document, and Malcat already tells us some interesting things. We could start with the upper left space. You will find all the files that have been found by Malcat, because Malcat it's an hexadecimal editor, but not only, it can inspect files, it can deep dive through files, it can disassemble. You will see there is a lot of things to do. And one of the features that I like is that for any archive type of files, you are able to explore them directly from within the tool. You don't have to unpack it on your disk, open it again, and so on. So in this case, it's a CFP file. So CFPs are also known as OLE files. Okay, so these are, for instance, old school Office files. And in this case, it's not a Word document, it's not an Excel document, it's an OLE which has different sections. You can see, yes, you can see my mouse cursor enough, I think. In the layout column there, you can see the layout of the file, so the different sections. For an OLE document, you have a directory in the files that just cuts the files in different sections. And you can see that the biggest section there is a section named encrypt package. Malcat also has fired up an anomaly encrypted region because it has detected that this region is encrypted. So what we are facing there, actually, it's an encrypted Office document. I don't know if you have played with Office a bit. I guess if you have analyzed any Office malware, you know from time to time the malware like to protect the Office document. And when they do this, Office will encapsulate the document inside an encrypted OLE container or a CFP file, and that's exactly what we are looking at now. So if we had a look, we could see that the biggest, there we are already in the encrypted section. Almost all the file is this big encrypted section. And in order to decrypt it, you can use external tools like, I don't know if you know some, Josh. Which one do you use to decrypt Office files?
I'm drawing a complete blank on that at the moment. I guess it depends a little bit on the tool, but I don't know. What do you use? I don't know.
A Python package. It's a MSOF crypto tool, I think.
Yeah. Okay, that sounds familiar. That's probably my go. This happens to me a lot.
I don't know if there are other ones, but that's the one I use at least. So we will then see the first feature of Malcat. It's scripting. If you do some analysis, run script. Malcat comes with some scripts to help you patch files or emulate files or any features that is not directly built into Malcat. And then, for instance, for Office, we have a small script, Office Decrypt, which, as you can see, will just decrypt a password-protected OLE Office document. Okay, this script is using an external library. It's a Python script. I can load it, and you can see it's really simple. It's just using the MSOF crypto Python package. And then it's just decrypting the current file of Malcat using different passwords. And the first one, Velvet Switcher, that's the password that Office is using by default when you just protect an Office document. Like it just encrypts it with this default password. So if we just run the script, it should work. And you can see, I will explain it a bit, that Malcat has already opened the decrypted file. That's what the script was doing. I could show it maybe. The script explicitly opens the file afterwards. And you can see also a nice feature, well, I like this feature at least in Malcat, is that you can open files directly from within the interface. There we can see that we started with one file with our encrypted OE file, and now we are viewing a second file, the result of the decryption script. And this file, we can see on the upper right corner, it's a zip archive. And not your typical zip archive. You can see it has a content type .xml file there. And also two XML files, app and core.xml, that we can find mostly in Josh.
These are the OpenOffice XML.
Exactly,
yep.
OpenOffice XML. So if you, for instance, double-click on the app.xml, it's just a text file. You can use the F4 view, the disassembly view. In this case, oops, not this one. In this case, we just show you the text content of the file. If you don't like the formatting, you can use this button there in the text view, for instance. That will open Malcat transforms. I will explain a bit later what it exactly does, this transform dialog. We will have more to do with it later. But let's just choose XML indent, for instance. And so we can see a bit better. What is interesting there is the application. We can see it's a Microsoft Excel file. Okay, so we are looking at a Microsoft Office file, open XML file. So now we want to close this XML file. So I will click there to close the current document and go back to the decrypted open XML file. So we are looking at an Excel document. So what I would do as a malware analyst there is my first reflex would be to look for macros or VBA macros, VBA objects, or Excel formulas, stuff like this. And in an OpenXML document, VBA macros, they are inside a project file, VBA project.pil usually. And there we can't see any. Maybe I will make this a bit larger. Exactly, we can't see any. There are some pictures there that we can have a look. If you click on a picture, Malcat will preview it automatically for you. And we can already see some suspicious pictures. There you can see some blurry image. So it's not my resolution that is bad. It's really an image that is explicitly blurry. It's used a lot by malware, in order to make you curious. Like, oh, I'm seeing something, but I don't see it really right. Maybe I did something wrong. Maybe I need to enable the macros in order to see the right pictures. It's some kind of social engineering. Okay. This picture is also interesting, of course. It's some luring, social engineering. Again, a blurry picture. What I find curious, usually you also get a picture that lures you into enabling the macros. And there we have an EMF files. Malcat has also support for this kind of files. EMF, that's a Microsoft, I think, image format. And there it is, okay. There we can see Malcat did some carving if you are doing some incident response, you are most likely familiar with the carving process. It's just the process of scanning a file, binary files, and looking for known type of files, like known zip files, known PE files, known images. Every file format that is pretty defined, that has a beginning and an end, it can be found inside any binary blob. If you are doing forensics, for instance, you will carve disk images, complete disk images, to look for deleted files. And Malcat can also do carving on any open files to look for embedded files. In this case, it just have found a DIB, a device-independent bitmap. And if we open it, we can see that, okay, there we have our typical luring images. Please enable macros and you will get the real document. Okay, but that doesn't tell us where the malicious stuff is, okay? I could have a look inside the Excel sheets to look for external references, maybe, to malicious content or formulas, but there is something that I find interesting, at least. That's two embedded documents. The first one, docm, seems to be a Word document. I can have a look. We can see again, summary view, zip archive, open XML document, like we have seen before. It doesn't seem to have any VBA macro, but also an image is there. Okay, it's the same image. So maybe, again, a luring document. Let's have a look. Oh, I went one too far. Let's open it again. Okay. Let's have a look at the second embedded objects. And that's an OLE object, 4 kilobytes. Let's open it. You can just double click, which it will bring you there. And you can see it's again a CFP document, OLE document, but a small one. And Malcat has something, at least in paid versions. It's not in the free versions, because I don't want that malware authors are too aware of these features. It's a big library of anomalies for most of the supported file types. Malcat is able to detect some kind of anomalies, suspicious stuff that he has found in the file, and that will give you some clues on whether the file is malicious or not. It's not an antivirus. Don't use it to detect. Don't use it to make your decisions at the end. It's just a help for the analyst. For instance, there we can see the first anomaly. If I click on it, files, embeds, and OLE objects. Okay, it's most likely this OLE native there. And second anomaly, vulnerable file type. In most of OLE documents, you have a GUID or CLS ID. I think it's a CLS ID, a class ID that defines the type of the document. And there we can see that the type of this document is Microsoft Equation 3.0. So, of course, Microsoft Equation, I'm sure most of you know they have been exploited a lot. Not so much nowadays, since Microsoft removes support for removes the binary from Office, but they have been used a lot to exploit some vulnerabilities in the equation viewer. And so if you look at this anomaly there, we can see that it has been detected in one location, and we go to the directory structure of the file, and the CLS ID is the one for equation files. Just a quick pause there. I just jumped to a second view that I have not presented, not introduced. You have two types of data views in Malcat. You have the hexadecimal view, which you should be familiar with. It's similar to what you will find in other hexadecimal editors. And you have the structured text view, which will expand all structures that have been identified by Malcat. It's really useful when you are looking for anomalies in files, or if you are just curious and learning the new file formats, or if you just want to know what you are doing. I really like this view. I use it a lot. And that's this one. And everything that is not in a structure, like this, will be just represented as text. Okay, so we are now aware that there is this OLE embedded object in this OLE document that is pretty suspicious. So just let us have a look at it. I just double-clicked it. And what is this type of file? OLE native. It's a file type specific to Office documents to embed arbitrary binary objects. And you have a small structure, that is, you have a small header that just tells you how big the binary data is, and then you get the data. And we can already spot something suspicious there, is that the native data size doesn't match the size of the data at all, actually. That's something you will from time to time see in malware, because actually Office completely ignores this field. Sorry, it completely ignores it because it's not needed at all. I mean, the size of the object, you can get it from the OLE document structure. So it's already something suspicious, something that in this case Malcat has spotted too. So just let's open this data. I have selected it there, and context menu selection. You can open it like any other files. You can open selection. Okay, I've opened it, and now we have binary data. So we know it's an equation object, and so it has something to do with equation, but I personally don't really know this format. I know it a bit, but not a lot. And you can see there is no support for Malcat at all. So we are just facing a binary blob, and we don't know really what we should do with it. The first thing I like to do is just explore the data in the data view, like we are doing there, and see if I can get some sense out of it. In this case, it seems there you can see all the different characters there, and it looks like encrypted data. How can I know it? Because the entropy of the data is rather high there. You don't see a lot of repeating characters. And when you select something also in Malcat, you get the byte distribution on the left there, and which also you can see that the distribution is rather uniform, which tells us it's similar to random data. So it can be compressed data, encrypted data. Okay. In the middle there, you can see the entropy is a bit different. It's smaller. And the byte distribution is also rather interesting. Maybe I will try to make this a bit larger. You can see there are a lot of zeros, okay? And also you have a lot of, I don't know if you see it there, E8, E9, and E9 bytes. And that's interesting information, because I don't know if you know, but in x86 architecture, E8 and E9, they are opcodes for jumps and calls. So that's interesting information. So maybe there is code there. We can have a look. I will switch to the third view of Malcat, which is the disassembly view. And since we are most likely looking at an exploit for the equation file format, it means most of the time that you will get a bit at the beginning of your file, you will get your usual equation structure, and at some points, the format will be exploited, and you will find in the files a shellcode. So our task right now will be to try to locate this shellcode. Okay. How to do this? What I like to do for most shellcodes is just browse through the files in the disassembly view. You can see there that everything is gray in Malcat. It's mostly because Malcat doesn't know if it's code or data. It's not a format that is known to Malcat, this equation file. So everything is grayed out, but no big deal. We'll help Malcat figure it out. And there we can find already a pattern that is rather interesting. It's a call followed by a lot of jumps. So in my experience, for this kind of equation, Microsoft equation exploits, the shellcode usually, the payload part of the shellcode, the decryption part of the shellcode, is usually obfuscated through spaghetti code. It means codes which is obfuscated via a lot of jumps that are not necessary. So maybe the shellcode starts there. So we will help Malcat. We'll just say force function start there. It will tell Malcat that at this location starts a function. We will also help Malcat in the CPU department. It looks like x86 code, so let's say it's x86 code. And you can see that already Malcat did something. It splitted the file in two functions. The first function, this one, that is calling the second one that seems to be a bit obfuscated through these spaghetti codes, like I've explained it to you. There you can see the proximity view of Malcat, which is a bit similar to what you can find in IDA. And you can see that the function is split between a lot of different jumps. And you have some kind of crypto, I guess. I would say, looking at this, it looks like a decryption function. So how could we decrypt it? You have different methods. Of course, you can do everything statically. I could try to reverse this. I could use the decompile view, for instance. I don't know if it will work well. Okay. I think it would be rather easy to write, to do it statically in this case. It's pretty simple. But I will use the occasion to introduce another tool, which I'm sure Josh will be familiar with. It's a Speakeasy emulator. Mm-hmm. So maybe you will want to introduce the tool, Josh.
I haven't used it much over the years. I think the last time I took a look at it was to do some shellcode emulation. So I assume I know that's where we're headed. So I'm anxious to see it again. But it is one of the many Flare tools. So I'm a part of the Flare team at work, which has nothing to do with the stream. And it's just one of the many projects that you can find on GitHub. So I believe the main purpose of Speakeasy is shellcode emulation. Maybe I'm wrong. I guess I should pull up the GitHub.
It is, and also it can also emulate whole PE files, actually.
Whole PE, okay.
Yeah, Speakeasy. So it's a layer on top of Unicorn. Unicorn, it's an emulation library which is built on top of QEMU. So we have QEMU, another layer Unicorn, and what Speakeasy adds, if I'm not mistaken, is it will emulate a functional Windows environment. Like it won't just it will support shellcodes that are calling Windows APIs, emulating these APIs. Something that Unicorn is not doing. For instance, Unicorn is operating system agnostic. But Speakeasy, it's really useful for Windows malware and Windows shellcodes. So also, in this case, it's not Speakeasy, this script. The library is not bundled with Malcat. That's something you will have to install yourself if you want to use it. You can find it on GitHub. Just Malcat is able to use it as an external tool. So I will load it. By the way, a small tip if you want to try this at home. A small tip. If you are in Windows, Malcat comes bundled with a Python interpreter. If you look there, in Malcat, you can see in static there, you have a Python 64 interpreter bundled with Malcat. But if you want to use external Python libraries, you will have to make sure to check this checkbox there, use system Python interpreter. In this case, Malcat won't use the embedded Python interpreter, but the one installed in your system. For Windows, it has to match the same, it has to be the same Python version as Malcat is using, which is currently Python 3.8. I know I should update it. Maybe it will come. It will come. I think Python 3.13 will add better support for sub-interpreters, and then I will use the occasion to update the Windows interpreter. But make sure to check this. Otherwise, Malcat won't be able to see all the libraries, the Python libraries that you have installed on your system. Okay? End of the remark. So the Speakeasy emulator, the Speakeasy script in Malcat, it's just rather stupid. It will just call the Speakeasy emulate shellcode on the first function that is defined in Malcat. In this case, it will be there, this one. The first function is this one, this goes. So I don't know at all what the shellcode is doing. I will just stupidly run the Speakeasy emulator and let the grid guys at Flare do all the magic for me. So we will run the shellcode, and at the end of the emulation, the script also opens the data as a new file. We can see we were in the OLE native, in the selection, and now we are in SC shellcode, that's the output of the script. And we can see that the data has changed. We can see strings appearing, which were not there before, and interesting string. So we could, again, open the shellcode in IDA or in a disassembler or in Malcat to look and to get what it is doing. But I think we have two interesting strings. There it looks like a download destination. We have an interesting API there. Okay, the shellcode will most likely download a file, and we have a URL, which we could try to directly download the file from Malcat. If you just select a string in Malcat, there is a context menu action, download selected URL and analyze. We could try it, but the file is from 2022, so I'm afraid it's not online. We could have a look. I'm curious, actually. I've not tried it.
Hey, Renaud, question from YouTube. I didn't understand how to access Speakeasy. Do you think you could?
Yeah, sure.
Do that.
You have first to download it. Well, let me go back. Actually, it's explained a bit at the beginning of the script. Okay, you need to install Speakeasy. There, I'm not sure if the URL is still actual. Maybe it has been renamed to Mandiant.
Yeah, it has, and probably will be renamed to Google soon. I got the link on the screen if you want to go and check out the project.
Yeah, perfect. Thank you, Josh. So just install, okay, this library, and then in Malcat, in the preference dialog, if you are using Windows, if you are using Linux, you don't need this extra step, just because the Linux version of Malcat is not embedding any Python interpreter, because in every Linux distribution you have Python. So I don't need to do this. But for Windows, I like that the malware is just, okay, you download it and it runs. You don't have to install Python additionally. It's so you have a Python interpreter that is bundled. So make sure in the general tab to have use system Python interpreter checked. Yes, of course, for the querying framework, it would be an alternative. I don't have a script that is that would do the binding work, but you could write one. I mean, writing scripts for Malcat, it's rather easy.
Okay.
If you want to have a look, there are a lot of things in Malcat. Almost everything that can be customized or expanded. Let us do a small parenthesis. In the Malcat, in your Malcat directory, you have a data folder there. And everything that is in this folder can be expanded or modified, overwritten. You can have fun. You have a script folder. Where is the script folder there? And there you can, for instance, you can find the Speakeasy shellcode. If you were to add another script there, for instance, for the querying framework, okay, just add a Python file there. For scripts, you just have to respect a small convention. It's to give some info at the beginning of the doc string, mostly the name. It will be used to be displayed in this dialog box there. And then your script is good to go and Malcat will use it. So feel free to add your own script. Okay, so let's run the script again. We have our URL and we have seen that, I won't say sadly, it's rather a good thing that after 2 years, the link is offline. And, okay. But I've downloaded the malware. It should be there. Okay. I will cheat a bit and just use this file to go on. Okay. It will be the file that is downloaded by the shellcode. And I will just make a small pause because we are switching files. If you have additional questions, don't hesitate to ask some.
Hey, Renaud, could you show me that IP again? In the shellcode. I was just curious if it's on the URL house.
I would guess so.
I would think so too. Okay, thank you.
A small additional note to what I've explained with the data directory in Malcat. If you modify stuff there are chances that it will get overwritten with the next Malcat update, because from time to time I change files there, and if you did any change, maybe I would overwrite them. So for this purpose, there is a let us close this one. There is a mechanism in Malcat which I call user data directory. If you go into the preferences in Malcat, you have the custom data directory that you can set up to the directory of your choice, okay? And that will be a directory. In this case, it's I've set up to my data that will mirror my data. Where is my data? There. It will mirror the same structure as the data directory in Malcat. The only thing is that Malcat will always try to look for files in your user directory before looking into its own data directory. So if you want to modify stuff, modify files, add signatures, add new parsers, add new anomalies, the good way to do it is to create this custom data directory and put your files there. And then Malcat will use them immediately. You don't, I think for all the files that are there, you don't even have to start the Malcat again. You just reload your analysis, reanalyze the current file, and it will use every change that you did to these files will be taken into account. Okay, so let's go on. Now we have our second file. It's a file with a big overlay. We can see in the summary view there, in the layout, we have a big overlay. Overlay, for if you are not familiar with the P file format, it's everything that it's data that has been appended to the end of the P files and that won't be loaded into memory when the programs run. Because of course we are looking at a P file. Overlays are used a lot by installers, and we can see there in the Yara signatures portion of the summary screen that there is this NSIS installer Yara signatures that has matched. But you shouldn't trust any Yara signatures, of course. If you are looking at malware, I mean, malware are tricky, and how can you be sure that it's really an NSIS installer? So you can look there in the bottom left panel in Malcat. You can see when you click on a Yara rule, you can see every string that has matched. So you can inspect yourself. Why did Malcat think it was an NSIS installer? And something interesting there, it's at the beginning of the overlay, there is this signature that is typical to NSIS installer. If I look at the rule, I can also open the Yara rule. You will go to the Yara editor inside Malcat, which is a rather powerful Yara editor, where you can inspect your rule and edit them. And of course, this rule, you can see it looks for this pattern there at the beginning of the overlay. So that's why Malcat thinks, or the Yara rule of Malcat thinks it is a nullsoft installer. But again, it doesn't have to mean that it's a real installer. It could have been backdoored, for instance, by a malware or patch, or if you want to be sure, what you can do also, it's called hexacode. That's an online service in Malcat that will perform function lookup. I don't know if you know Intezer, for instance.
Yeah, I do. Yeah. I haven't used it in forever now that you mention it, but I used to love that service, and the idea, I helped guide a number of dissertation topics along those kind of code similarity lines.
Yeah, that's the same idea. I mean, you could define it as the integer for the poor. Okay, if you don't have money,
Sure.
it comes free with Malcat. I mean, if you have a paid version of Malcat, okay, you get access to hexacode, to the hexacode lookup service. If I click on this button, Malcat will compute hashes, smart hashes, of every function and also every string. There I'm switching to the string view. Of every string it can find in the malware, send it to my server. So I only get the hashes, so it's a bit privacy friendly in this sense that I won't get your sample. I will just get some hashes. I can't do a lot with them. So, okay, I just perform then a huge lookup on my database, and it will give us results. So let's click on it. Oh, that's not normal. Oh, that's totally normal, actually. You can see 0 hits. Why? Because I have not clicked on this. When I say show clean stuff, for instance, it will, and show unknown stuff, I will click on everything. It will show me every function that is known, that has been found in my clean set. Okay, I have a huge clean set on the hexacode server of millions of clean files. And same for the strings. All these strings have been also found in some clean files. If I go back to any view, like the data view, we can see that a lot of stuff has been changed there, has been colored with the result of the hexacode query. And for instance, all these functions have been found in some clean program, most likely also a nullsoft installer. So if I do a quick lookup there from the text section, I can see that almost all functions have been found inside clean files. And the small ones, if you are curious why weren't they found inside a clean file, is because Kesa code won't send hashes for small functions, because most of the time that's useless. Small functions are found in a lot of different files, clean, malicious. You have a lot of false positive on this and false negative on these small functions, so they are not sent to the service.
Sure.
So we can be pretty sure it's a completely clean standard. Right. Actually the program, the code is a nullsoft installer. So it means we can completely ignore the code and just focus on the installer archive. There we can see in the car file again, Malcat was able to identify the installer archive, and we can just double click on it and it will open it inside Malcat. So a small bit of background on nullsoft installers. Nullsoft installers, they are just archive of files, okay? They are packed inside inside using a custom format. You have two different types of formats. Actually, you have the solid one and the non-solid one, but I won't go into too much details. But there you can see you have 3 files inside this archive, and one setup script, that's the install script. Because installers, setup or NSIS, they are using some install script to drive the installation of the program. So let us just have a look at this setup script. So NSIS scripts, they are programmed using a custom virtual machine that we call NSIS VM, virtual machine, okay? You can find some disassemblers online for NSIS or unpackers. But Malcat, if you are using the non-free version, you also have the disassembler for the NSIS VM. And you can see a bit, you can see there a strong point of Malcat is that it bundles a lot of different tools to make your analysis workflow faster. Okay, like you will find an NSIS decompiler as open source tools, or you will find a disassembler, you will find a Yara scanner, but to have everything in one tool, at least for me, it allows me to be much faster when analyzing malware and white-team detections.
Yeah, that's a common workflow, isn't it? Because you're dealing typically with a lot of different stages that have different technology, and then you get one layer peeled back and you realize, okay, I've identified this new thing and I need to figure out how to handle it and deal with it and find tools that can help. And you move on to the next layer, and it can be a really slow and cumbersome process. And to see all of this workflow done in one tool is really streamlined.
Yeah, exactly. I also don't like to alt tab between 10 different tools just to get the piece of information that I want.
Right.
I'm a bit lazy, and if I can have everything in one tool, I'm happy. So there we are again in the disassembler view, and we can inspect the NSIS script. One function that is interesting is on init functions. We can look, first I will go to the symbol view there, and we can see that 4 different functions were defined. You have these on-init functions, which is called by the NSIS installer at the beginning of the install process, and 3 functions with random names, okay? So we start at the beginning with the on-init functions. We won't go deep into details, but for NSIS installers, what is really interesting is this extract file instructions. it tells the installer to extract one file that it from the archive to the disk. Okay, there we can see that it extracts two files, the two that have been seen inside the archive. Call this function. I don't know what it does. Okay, looks like it has something to do with plugin. Initialize some plugin. Okay, let's go back. And then extract a third file also into which looks to be a DLL, seems to be a DLL. Okay, and if we look at the rest, then we have a register DLL. So the DLL, the third file that has been extracted, will be called, and this export from the DLL will be called. After that, we have a lot of, if you are a bit familiar with NSIS, it's junk actually. It's not valid code. You can see that the strings there, you have a gibberish strings made of random words taken most likely from a dictionary. And that's just garbage, to fool antivirus, to make the script a bit bigger, because normal install scripts are bigger and they use functions that's basically useless. The important part is 3 files are extracted and this DLL is called, the third file there. So let's go back to our NSIS archive. So I think we have seen everything we wanted to see from this install script. So let's have a look at these files. I will open the first one, lognp. Just there, I've opened it inside a new tab using Malcat. That's also something I like. You can open files in parallel, and afterwards you can switch between files using this file switcher. I will use it a lot for the next part. So the lognp files, the type is unknown, as we can see there. So no known files. And if we have a look using the hex editor, we can see we don't see any string. We can see repeating patterns there. And if we compute the entropy there, we can see also, okay, so it's not packed, it's not compressed, but it's most likely encrypted, I would say, using a 1-byte cipher. We could try our luck. We can see a few patterns that are repeating, but I could try to XOR, okay, like this B2. We could try using a Malcat transform there. Just XOR the selection with B2 because it seems to be repeating a lot. Do this in place and nothing. Okay, so it's not your typical XOR. Let's undo this. I can edit undo. Okay, I have my original file, so I don't know what this file is. Let's have a look at this file. This file, also not a known file type. And if we look there, you can see on the right, I don't know if it's clear, this red bar next to the scroll bar. It's entropy, and you can see it's red, bright red. It means entropy is high. And it's high all along the file. So there, it's either compressed or encrypted using a longer key. So no luck with our files. So the third file, Malcat did not give it a name because I won't go into details, but files in NSIS archives are not named. They don't have name. It's just the script that gives them name. And for this file there, we can see that in the name there was some variable. And Malcat's file parser at this stage of the parsing was not aware. It did not have access to the disassembler, so it was not aware. It could not reconstruct these strings there. So it just gave another name, which is the offset of the file there in in the archive. So if we go back, this file, it's actually our DLL. So let's open it also in a new tab. And then there we have our DLL. I don't remember exactly which export was called. The DLL gets extracted and okay, SDVFF, okay. We'll try to find it in the DLL. So we have our DLL that is dropped to disk. And we know that one export will be called. So let us have a look. Okay, it looks to be this one. Also funny, there you can see in the symbols, they are all in colors. It's because Malcat has found some anomalies. There you can see why, which anomalies. It's this one, for instance. It's anomaly defined over functions that have more than 48 unique bytes defined across all immediate operands. So if I check this function, for instance, you can see it has a lot of immediate constants in the disassembly, which is most likely a sign, a tale of obfuscated code, okay? Doing some arithmetic obfuscation. Also, you have as an anomaly, which is interesting, a XOR in a loop. Okay, a XOR instruction has been found inside a loop. It doesn't mean, again, that it's malicious. In Malcat, anomalies are just pointers for the analyst to look at interesting stuff. So if I just have a look there, I can see a XOR instruction that is highlighted. Also, a quick note, in most of the views, like this one, you can highlight different stuff. Just press Tab, the Tab key. Keep it pressed, and you can select what you want to be highlighted. In the disassembly view, for instance, you can highlight different instruction type. But in the data view there, for instance, you can choose if you want to see headers or not, metadata, you want to see functions or not. You can do you can configure it to your liking. Also, for instance, references, cross references. I can see like this green colors inside the blue. Maybe if I remove the blue, you will see better there. The green stuff, they are incoming references. You can see there, if I click on it, for instance, that there is a code reference to this part of the file. It's also pretty useful. You can also activate it or not. You can dim zeros. And you can customize it to your liking. So don't hesitate to use this. It's a tab key. And so let's go back to our anomalies. Also, possible Packer API dynamic import. Let's just click on it. It just means that we have found a Packer-related API, like virtual protect, resume thread, one API that is used a lot by packers or cryptors. Or it has been found as a string, but not in the imports. So maybe it will be imported dynamically. Let's just click on it there. And indeed, in the RData section, we can see there is the string virtual protect and kernel 32. But if we look into the symbol there in kernel 32, we can see that virtual protect is not imported. So that's pretty suspicious. If I were, for instance, if I were to write a detection for this file, I would use these strings because it means something. And why is API virtual protect not imported? You may ask. It's most likely to evade antivirus detection, because antivirus scanners, they look at the imports, and virtual protect is a really suspicious API used in a lot of malware. So malware authors, they try to hide it. Okay, so our DLL is suspicious. That's clear. That's pretty clear from 2022. And we know that this export will be called by the setup script. So let's just have a look at this function. We can see at the beginning already something interesting there. It's a stack string. A stack string that is a string that is constructed dynamically on the stack. Also, something that is used from time to time by malware to conceal strings. And in this case, log NP, I don't know if you remember, it was one of our NSIS file. Okay, it is a file inside the installer archive. So interesting. We can see an API call there, get temp path, create file, okay, read file. So if I had to guess, I would say the code will just open the log NP files that has been written to this by the installer and read it. And then we have we have our XOR in a loop, okay, this anomaly that we have found earlier. So some kind of crypto, okay, and the loop counter is you can, if you want, small tip also, view hexadecimal numbers. You can switch it or use a shortcut Ctrl-Shift-D to switch between hexadecimal and decimal. Okay, it's a file. It will be iterating this number of times. And if we look at our log NP files, it's also exactly the size of the log NP file. So I would say it is iterating over every byte of the log NP files, doing some things, and then, okay, there we have our virtual protect reference, a dynamic import of the virtual protect library that will be called, and I would suspect that then the log NP files will be executed as a shellcode. So, okay, perfect. So let us decrypt this log NP file. So there, it looks to be a bit convoluted. Okay, a lot of instructions. Let us use Malcat's Decompiler. So we can press F4 or just click on this, and there you will have the decompile code for this function. For information, it's using the Slay, I don't know how to pronounce this, the decompiler that is also used by Ghidra.
Yeah, yep, I think that's right.
It's the same one. So in this case, we have our call to APIs and also this part, which seems to be the decryption function. Okay. So thank you, Ghidra, and we have it a bit nicer there. So let us decrypt this file. So what I will do, I will switch to the log NP file, select everything, Control A, for instance, and then use Malcat transforms. Let me switch again to the DLL because I forgot. Okay, we do this so that we can see both. Okay. So now I will talk a bit about a nice feature of Malcat. If you are familiar with CyberChef, for instance, the website, it's a bit the same idea. Malcat features transform, which are small algorithms, small functions that can be linked and combined to perform decryption, decompress stuff, change the encoding of strings. You have a lot of different transforms. You can also add your own also if you want. And like in CyberChef, you can link them and in order to decrypt your malware. It's really the same. So in this case, we will try to decrypt our log NP files that we have there into something that makes sense. So we just follow what the code is doing. For instance, we can see the first operation seems to be -3. So let us look at, there we have a sub. Just double click on this. And let's just put 3, okay. Next is a XOR, okay, with F2. Just do this, F2, Sorry. Hexadecimal it is. Then we have an add with 11, hexadecimal again. Then we have a XOR again with hexadecimal, please, 28. And then this is a comment that is added by Malcat, because this number is also equivalent to this ASCII character. And then we have a -1 there. So let's do it again, -1. Wait, there was an issue there. F2, okay. Okay, perfect. So I fixed my mistake. So there we have the whole chain. By the way, if you want, that's a feature that will be available in the next version of the tool. You can save your template, your chain, using any specific name. I don't know, shellcode decrypt. And you can save it. And later you will be able to recall it. That's a nice feature. You can also add your own Python code if you want, using an inline Python operator, online Python editor, sorry. You can do a lot of things there. You can also add your own transforms. Again, you go to the data directory of Malcat, transforms. You just put a file in your, for instance, my transforms. And there you can write your own transforms, okay? If you want to have some example, you can use existing transforms there. There are just some Python functions. You can write your own. It's really easy. Just write your own, and Malcat will use it automatically. For instance, let's just take, no, I won't do it now. I think there is a lot to showcase in Malcat. I will have to stop somewhere, but it's really easy to add your own, and it will be available in this dialog immediately. So we have decrypted our data, which looks a bit weird, but if we look into the disassembly there, we can see that it looks like code, okay? We have a jump, and then we have something that looks like your typical C prologue. So we have some code. Let's decrypt it inside a new file that will be opened also in Malcat. So we have some code. Again, we have to tell Malcat that it is code because it can't know. I will force a function start and then tell him it looks like x86. I think it's not x64, no. Looks like x86, okay? So let us have a look at what we have there. The first function is, again, we have this tag string there. Okay, maybe looking for some APIs. Let's have a look at this function. This function is interesting. Let's switch back to hexadecimal view. So I guess if you have followed Josh's video not so long ago, you can recognize this pattern. So that's some code that is accessing an export table. There you are looking into the PE format, and this is export table. And so it's most likely, I would say, if I had to rename this function, it would be API lookup. Looks like API resolution. And I'm pretty sure because it's referenced a lot of times. So looks like API, dynamic API resolution, using hashes, if I had to guess. By the way, you can modify a lot of things in Malcat, and everything, if you press Ctrl S, will be saved. Your annotation, everything that you name inside a project file, like IDA, that will be loaded the next time you open the file. So, okay, that was our API lookup. Okay, it has been renamed everywhere there. And then we have something interesting. We have also another stack string And this one, I don't know if you remember, it was also one file, the name of one file inside the NSIS archive. So that is interesting, okay? It seems to access this file. Sadly, we don't have the API there because we know why, because the APIs are resolved dynamically, okay? So we could try to write a script to resolve the APIs, but with some experience there, for instance, you can tell that this looks like a create file. I mean, the first parameter there, it's most likely read access. So most likely the files will be read, okay? Other APIs that I don't know, or also could be a virtual alloc or virtual protect. Okay, and then we have a call to this function. Let us have a look. This function, this function looks also interesting. Lot of arithmetic stuff. Let us decompile it using F4, and you can see, okay, it's a function that takes two parameters. The second parameters, param2, looks like it's a size, because we have a counter that is incremented every time. And okay, we iterate as long as our counter is smaller than this, so looks like a size. And param1 looks like some kind of buffer that is modified in place using this. So I would say it looks like a decryption function. Maybe it's a decryption for our file. For this file, if you remember, it looks like encrypted. Huh? We couldn't make any sense out of it. So maybe it's our decryption file. Let's rename it. Decrypt stuff. I don't know what, but I'm pretty sure it's decrypting something. Okay. So we have already a lot of information. What this shellcode seems to be doing: imports some APIs, open these files, and decrypt it. So now we would like to decrypt our file, but how to do it? The issue there, I can't use an emulator directly because the file is not embedded inside the shellcode. The shellcode is accessing the files using API calls like read file. So the file is on disk, not inside the shellcode, so I can't just emulate the shellcode and I will get a result. But let us be smart there. I could write write a hook inside Speakeasy in order to return the file when a call to read file is done. But I could also be a bit smarter and just embed the file inside the shellcode. Let us just select the whole file there. First, let us look how big it is. Okay, I will just there. I can copy the size of the file. Let us go to our shellcode, go to the end, and there I will just right-click, insert bytes, and I want to insert this many bytes. That's the size of my file. Okay. Malcat will insert a pattern there. So, okay, your shellcode has been expanded. So now let us go back to this file, select everything, yes, and just copy, okay. And now we can go there. If you want to edit something inside Malcat, inside the data view, just double-click or press insert also. Or just right-click and you can do edit bytes. Yeah. Okay, I will just paste what I've copied, so the content of the file. And now we have our file there. It is this file, the content of this file has been pasted there. Okay, so it is this. In order for me to keep track, I will just select it and also use another feature of Malcat, which are user annotation. There I will just say it's the NSIS file, okay? So I've named this data there, NSIS file. So it's a bit clearer for me as an analyst to know what I'm doing. You can see now also there is a symbols to this added annotation. Okay, and now I would like that this file to be decrypted using the decrypt function. Decrypt function decrypt stuff. I would like this function to be called on this buffer. So a quick and dirty way to do this is just to patch the shellcode. Like we know that the decrypt stuff function just accepts two arguments, two parameters, a pointer to the data and the size of the data to decrypt. So we will just patch the beginning of the shellcode there with a call to this function with the two parameters. So first we'll push the size, because in this calling convention, you start with the last parameter first. So let us paste the size of the buffer, and I don't remember it, of course. So let us just select this, select, and there we have the size again. Okay. Let us go back there, and in our push, I will just patch this. Okay. Oops, no, it's in decimal, so let us do in decimal. Okay. So now we have a first push. We just pushed the size of our buffer. Go to the next instruction. Push is 68. And now we need to push a pointer to our buffer. So our buffer is NSIS file there. Right click there. Copy address, virtual address. Okay, we'll go back there. I will edit these bytes. And hexadecimal again, please. And up. And you can see that Malcat already resolved the address to our annotations there. Okay, and next I need to make a call. So opcode for a call, it's E8, if I remember correctly. Yes, and I want to call our decrypt function, which is at address A01. So I will copy this address. And I don't know if you are familiar with x86 assembly, but if you want to encode a call the D word there, it's the deplacements starting from the instruction following the call to where you want to jump. So there I will use a calculator in Malcat to compute it. I want to jump to this. That's the address of my file inside the shellcode. But it has to be relative to the function just after the call. So in this case, address is F. So that's the displacement. I will just copy it and patch there. Hexadecimal, yes. Okay, so Malcat again resolved it. We are calling decrypt stuff, and then since we are polite, we will end with a return. Okay, I can analyze again the file. Okay, so now we have patched our shellcode and we call the decryption function immediately. Let us fire up Speakeasy again and see if it works. I hope it will work. Okay, no demo effect. We are lucky. So now it looks like the file has been decrypted and the carving algorithm of Malcat found the PE file, which is good news. So let us just open it. And now we have a file which looks interesting. We can see already some Yara signatures that have matched. Password stealer, browser stealer, we can have a look. Of course, these strings are pretty suspicious. We could look inside the online intelligence to see if some scanners know these files. There, Malcat will submit the hash of the file, SHA-265, to a lot of scanning service online, like VirusTotal, Malware Bazaar, a lot of different ones. You need to set up Malcat for this to give your own API key. But once you have done it, I mean, it's pretty convenient. Malcat will query all these online services, and you can see that a lot of these services detected as a malware, of course. And we have some Ferret, password stealer, Lokibot, also password stealer, okay. What do we have there? Again, yeah. Okay, the sandbox, Lokibot, looks like Lokibot. Let us confirm, for instance, with Kesacode. We'll also perform a query. Okay, Kesacode they're pretty also confident that is Lokibot. It also has some partial matches on different families, but it's most likely because password stealers, they tend to use the same strings. I mean, you don't have a lot of different files to steal, so you have stealers stealing the same files, of course, at some point. Like these strings, you can see it has been found in different stealers. But, okay, it looks like to be the lucky stealer. And I think I will stop there because it's running a bit late, I guess. You could try as an exercise to decrypt the configuration of the loki. It's at the end of the file. In the .x section there. If you follow the blog article, you can decrypt it. But I think it's a good time to stop our small example. I've tried to show as many features as I could.
Mm-hmm.
There is still a lot to show. I think you could do a session on just transform or on just scripts. There is a lot to tell. But I just wanted to give an overview, and I think it was an overview over most of the features, at least the ones that you will use at the beginning.
Yeah. I sense a Malcat live stream of its own could be born out of this.
Yeah, no, I won't make people endure my accent.
Oh no, it's been no problem at all. Yeah, that has been great. I mean, I knew that it was capable, but seeing all of it in action definitely was eye-opening. And how quickly you're able to get from just kind of go through the different, not only the different technologies and the obfuscation, but as you pointed out at the beginning, all in one tool. Usually a workflow like this, I'm bouncing all over the place. It's why distros like the Flare VM and Remnix have so many different tools installed. Let's see. I wanted to just bring up a couple of comments here for you.
Yeah, sure.
Drew said that great to see the support for other files. So he was initially thinking it was only PE files.
Yeah,
so
sure. It has really support for more than 50 file formats, I think. So usually, if you see a file format used by malware, Malcat has support for it.
Okay, yeah,
and if
yeah,
not, I'm most likely working on it.
Yeah. Okay. Yeah, someone asked about support for files. Yeah. So there's your answer for that. Yes. Lots of file support. I'm sure it's all listed on the website, or you can
just no support for Mac O files because Malcat itself doesn't run on Mac. I know it's a stupid excuse, but I should add it. But, yeah, that's the only exception.
Was a question about what databases does
PostgreSQL.
PostgreSQL. Okay.
It's a big database. I think you have some statistics. If you just hover there, you can see 30 millions of unique functions, 21 million strings. Postgres is great. I mean, it runs really fast, and it's really a great software. Software. So what I wanted to add also, I encourage you to use the free version of Malcat. It's already capable. I mean, you will find most features, like you will miss a few of the CPU architectures and the decompilers, but you will be able to analyze x86 files, and you will have scripts, transforms, you will have a lot of stuff already. So don't hesitate to give it a try. And you will see, I mean, Malcat, if you take every features one by one, it's not the best in for every one of these features. It's not the best tool for the task. You will find better disassembler, you will find better decompiler, you will find better Yara editors, but you will what you have to see is that everything is in one tool, and it's pretty convenient. You have a few original features that are a bit original, like the anomalies or the Python bindings. To be honest, I think I'm a bit proud of this. It's nice to have, and I think it's pretty useful. Hexacode, also the lookup, the hash lookup, is also pretty useful. But for all the other features, the point is to have everything in one tool and to be able, for instance, I'm inside a function. I want to add this to one of my Yara rule. I can use it. Just okay, add to this Yara rule. Up, it will add this what I have selected inside the disassembly view directly into the Yara editor. So you have this back and forth between features, between the different views. That is pretty neat, I think.
Yeah, absolutely. That's really cool as well, because that's another common task actually is creating Yara from the code analysis.
Exactly.
Yeah, a lot of great feedback. Really nice overview, and let's see, comment here. Katai struct support could be cool as well.
Yeah, I've thought about it, and maybe I will add some support for Katai. But the problem, I think, is that I would need to embed the parser for Katai, not just the scanner, but the parser, and the license, I think, is GPL, so that's an issue.
Yeah, for sure. Well, I think we are probably to the end. So we got any other questions or comments? If anyone has them, please feel free to use the time now. Of course, this will be posted in perpetuity on YouTube, so comments will be open there as well. If you want to come back and drop comments there or questions, I'll do my best to keep up with those. And if I need to reach out for some help, Renaud, I might message you as well. Malcat.fr. I already shared that link a few times, but you'll find that's where you can find the tool. You can get the demo version and get started with it today. There's a community on Discord as well.
Thank you, Martin.
So there is a lot of opportunities to not only learn, but get involved. If you're new, if you were able to follow along with everything in the demo today, then you're doing pretty awesome, because that was a lot of different stages, and being able to dissect it here on the fly and have sort of a technical understanding of what's happening is really important in this field. So, great demo to follow along with using the tool or other tools, I guess, if you'd like to. Whatever your workflow is, if you set that aside for a moment, just a great workflow. So, anything else that you wanted to talk about or share before we wrap things up officially? And I mash that end stream button.
Not really. I mean, thank you again for having me there. Really liked to be able to showcase the tool, and also saying I'm a big fan of what you do with your stream and your Discord server. I think there is a good vibe there. Everybody is welcome. And
well, thank you.
I think it's really nice you are helping the community. That's pretty great.
Yeah. Well, thank you. I appreciate that. It's a new endeavor for me. I guess 2024 has been a lot of new for me as well. And so if anyone is not aware, you can go to my website. You can find, I'll remove your messages there, thecyberyeti.com, and you can find a link to the Discord, as well as all the other things that I try to contribute and help out with. I don't have any tools nearly as feature complete as something like Malcat, but I got a handful of little things out there. But thank you for what you do. I mean, it's one of those fields that there are so many folks that do so much, provide not only to the companies they work for, but to the general broader community through open source projects. And and even free versions can go such a long way. And a lot of times not seeking the attention that comes with that. So I just enjoy teaching and sharing knowledge, and this is an opportunity I think to help share others knowledge. So really appreciate you taking the time to come on and provide such a great demo and all that you do as well. So if there's anything I can do in the future, let me know.
Thank you. No, you can always submit feedback if you have any feedback about the tool. Don't hesitate to reach me on Discord. You will see on the on my website, you have a link to our Discord server. So if you have any idea, feature request, or just bug report, just go there, and I'm usually pretty reactive.
Okay.
Just a side note, you have to also keep in mind, Malcat, I'm developing it on my free time. Okay, so it's a side project. So don't expect very huge features like, oh, can you add a decompiler for this architecture? Like, well, it may happen, but it will take some time. So
another common characteristic or tendency, I think, for those of us in this field is our side projects and hobbies and things are usually pretty extensive. I would say this is one of those definitely pretty extensive. Not hobby anymore, but side projects. So that sounds great. I think that's it then. I don't see any other questions. Just double check one last time. So I think we can wrap things up. Thank you again, Renaud, for your time. Thanks everyone for joining, and looking forward to the next live stream with Kyle Cucci, author of Evasive Malware, in just under 2 weeks. So join the stream then, and Renaud will probably have to do another stream here sometime later this year, maybe early next year. I think we've got plenty of topics we could talk about. I'd love to learn more about how you do your signature database. So if you're willing to talk about that or something, I'm sure we'll find a topic.
Okay, then thank you, Joss, and thank you everybody for having the patience to hear my stupid French accent. And have a good night, everybody, and maybe see you on Discord.
Okay, all right, here we go. Bye all.
Bye.